remember ever hearing that before. I guess so. All right, well, my name is Robert, and I'll put my little name tag up here, and that's what I'm going to ask you to do. So what I did is on these pieces of paper, I marked two. You can see two little black marks. That's where, if you fold them right there, it'll turn out just like that. Okay? And I left a marker on your table. Please write your name, just your first name. Okay? And legible. If you want to print it, it's probably a little better than cursive. There you go. Everyone's here for Cal 2, right? I think there's an extra one there. You want to be back there? No?
What are you teaching like up the front?
I'm up the front and then back here also. Whatever. I mean, I just don't know how much room you're going to have there. I think there might be 4 there. There's extra. You go by whatever name you want me to call you, all right? Can you see the little marks? So if you fold it into 3 pieces, then you can make a little tent out of it like this, and then use the marker in front of you to write your name. While you're doing that, I will, I'll wait. So just keep it in front of you, and then, you know, at the end of class, take it, put it back in your folder, and just bring it every day. All right, it's worked. I tried it for the first time last semester. It worked out pretty good, and then people just stopped doing it, and so I'm an average mathematician, but I'm a horrible at memorizing names. All right. Did you have a good break?
Oh, yeah.
All right. You're ready to come back, though, right?
Come back. I only did
Me too.
the worst one. The worst one.
Me too. Worst one? What do you mean, worst one?
Calculus 2, the worst
Oh, that leads us to my first question. You know, what have you heard about Cal 2?
one. Backwards.
Nothing good? Taylor series? Pre-Cal on steroids? Really? Okay, I haven't heard that one before. All right. Well, what I thought I would do here to start off is everyone's got their names out there, right? Just to make sure everyone has been to Canvas and has, how many of you have watched the orientation video that I sent an email out? Anybody that has not, raise your hand. It's not like I'm calling you out, you're in trouble. Okay, did you get the email though? There was an email about it? Okay, make sure that you watch that because I'm not going to go through the syllabus today, all right? It's your responsibility to do that online. And it shows you where everything is. Were there any questions about where to locate anything? Is everybody clear that that camera is recording everything I'm saying and everything I'm doing between these 2 lines? And that this will be posted on YouTube later today? Yes? Okay, I'm doing something a little different. I'm using a higher resolution on the camera, which means the file sizes are going to be bigger, which means the upload's going to take a little longer, and then the rendering, which is where YouTube processes the video, is going to take longer. So it may be an hour or 2 after I upload it. I don't know. I don't know what the processing time is going to be. If it's too long, I'll go back to a lower resolution, which shouldn't, I mean, those are sufficient also, but just going to try it out. Okay? So everyone's clear on where things are? Okay, there's a quiz, right? You have a quiz to take online? It's down here. It's due on, what is that, Thursday? Friday? Okay, I think it's 11 a.m. But it's just a yes or no. It's like you signing the syllabus saying, I understand the requirements of the course. So make sure you take care of that. Nothing else, I don't think. Where do you, if you were here, how would you find my videos? Where are they? Class videos?
Class lecture.
Right there, class lecture videos, right? So you just go there. I know that seems obvious, but I'll have students ask me, you know, where are the videos like halfway through the semester? I'm like, really? Okay. My condolences to your Hawks. Hey, they fought hard in the second half.
It was nasty.
So, what videos are online? What's going to be there for you, just to make sure everyone knows? The class lecture videos are there, and the homework videos, which means that I've worked through all of the homework problems, with the exception of the first 2 sections or 3 sections. 3 sections. I didn't do those because those are kind of basic stuff. So, starting from 5.5 on, I've done all the homework problems on video, and so you can go there and hopefully watch them. So that leads me to what I want to show you next, which was I asked last semester in my Cal 2 class to, on the final, it was a bonus question. I asked them to give my Cal 2 class this semester some advice. So would you like to see their advice? There's a theme I think you're gonna start to see. The advice I give: review DiGiovanni's videos and do every single homework assignment to keep up. But don't just watch the videos. Try the problem yourself before watching DiGiovanni. That's me, I guess. Solve it. Also review factoring. L'Hopital's rule. How many of you have no idea what L'Hopital's rule is? It's okay. Show of hands. All right. L'Hopital's rule. All right. That's something that's usually covered in Cal 1. Sometimes it's not. If you have not heard of L'Hopital's rule, please get with me. I'll refer you to some videos, some sections in the book where you can go and take a look at that. Most importantly, this was weird. I don't understand this. Don't bother DiGiovanni. My last name is DiGiovanni. Sorry, Robert DiGiovanni. Begging for a bonus. He doesn't like that. I guess I gave the impression I don't like people begging for a bonus, but I don't know about that. All right. These are student feedback. All right. I like this one. Without the willingness to learn and apply, this class will be extremely hard. Recognizing patterns in the homework will benefit you a lot. A difference in grade by about 15 points or so. I like that first thing. A willingness to learn and apply yourself has to be present in this class. Do all the homework. That's the third one that's mentioned homework, hasn't it? You might understand what's shown in class, but to do some of the problems on your own requires a ton of practice with different methods and different problems. You'll have to learn to recognize what processes need to be completed on a problem, as there are many. Let's see. I'm not going to read all these. Let me just kind of point out the big ones. Something about biting you in your ass. If you don't pay attention to small details, ask questions. You can get left behind way too easily in this class. All right. Do your homework, go to tutoring, find a study group, right? Do whatever it takes. Just make damn sure you know the material before the test. Don't do what I did. Ooh, that one has a name. Practice the problems you do in class when you get home every day. I can tell you right now this was a B student for sure. I know who this is. Make sure you know your algebra because that is where you'll mess up the most. Keep up with the homework again. If you skip the homework, come back to haunt you. Instead of memorizing the work, understand it. See if there are any more in here that are worth. Oops. Get off of there. Take advantage of the resources provided. Homework videos. Keep up with the homework. Don't just copy the homework answers down from the videos. Do it on your own. Use the videos to check your work. I'm not going to read through this one. Go to office hours. Don't get in a car accident the last week of finals. In Cal 2, it is important to keep up with the homework again. All right? Attendance is important, even though there's videos there. Nice handwriting. Definitely keep up with your homework. Utilize office hours. Form study groups. Well, given the fact I'll be taking Cal 2 again, okay? So what are they saying here? Take advantage of the online homework tutoring as well as flexibility of flexible availability for tutoring. So homework will make or break you in this course. So that's it. What I thought was important about that is, you know, no matter what math class you've ever been in, they've always told you, hey, you got to do your homework, right? All right. Now, I'm not telling you that. The people who took this class before you are telling you that now. All right. Because if I tell you, I'm not sure how serious you're going to take that. And these are students who excelled, did well in Cal 1. And if you have the attitude walking in here that, hey, you know, math has never been hard for me. I walk through this stuff in my sleep. This class will humble you. All right? So you have to stay on top of it. All right? I don't think so. I don't think so. It was no big deal. Thomas said yes, but you know, you would have to change syllabus stuff, and let's just leave it alone.
For sure?
Yep, it's no big deal. Thank you. I texted you. Did you get it?
Oh, I have my phone.
Ah, okay, sorry. Okay. All right, so hopefully I don't have to you know, babysit you on the homework, that you'll try it, especially with those videos out there. There's really no excuse for, hey, I didn't know how to do this, you know. You know what I'm saying? Okay. All right, what is next? I have a little list of what I want to do here. So what is, do you want to know how my last semester did? Would you like to know how their grades were? All right, so this is only one semester, all right? But this is the only semester I've taught Cal 2 where they had access to all the homework videos. That was the first semester I had done that. So I'm going to break it down by exams so you can really see like where students struggled. First of all, there were 30 students that started the class, and I had 24 at the final. That was a record. That had never happened. And that almost happened on accident because what happened was our third exam took place after the drop date. I think if that third exam would have taken place before the drop date, we probably would have ended with like maybe 16, 18, something like that. So it was, they kind of, I think they voted when they wanted it. I don't know. But, all right, exam one. Exam one, the average, y'all seen this before? X bar for average was a 71. The range in scores was 98 all the way down to 38, and I had 24 people at that test. So I had, at the first exam, I had already dropped down 6 students, and it never changed from that point on. Those 24 hung through the rest of the class. Exam 2, the average was 83. The range of scores was 103 to 60. I had 24 students there. Exam 3, the average was 69. The range was 102 to 39. And then the final, the average was a 64. And it ranged from 105 down to 15. 15 is the low. All right? So, oh, and then at the end of it, at the end of everything, for the class, final grades, okay, the average was a 73 in the class, and I had 3 A's, 6 B's, 5 C's, 5 D's, 5 F's. So 14 of the 24 got through the class. All right? Now this is not, you know, what I'm not trying to do to you is what happened to me when I was in pre-cal in college in an auditorium of 220 people. The professor walked in there and said, you know, I expect to see like 20 of you at the final, you know, and maybe like half of those to pass. I'm not trying to demoralize you. What I'm just trying to do is show you really where the problems might occur. The first exam, I believe, is weighted different than all the others.
Yeah, it's 15.
What happened? I got logged out. Oh, well. All right, well, yeah, I think this one's 15 and the rest are 20, and then the final's 25 or something like that. You can look at it, but just be aware that that first exam is not as heavily weighted as the others because there's not as much material on this first one as there are on these. And these two exams are by far the hardest, all right? So you want to try and do your best on the first two so that you give yourself some cushion for these two, because those are going to be the ones that really challenge you. That's where we get into the Taylor series and all that stuff. Yeah. Okay. Any questions about this? All right. Tips and feedback, we've got that. What's Cal 2 about? That was the next thing I had on here. So what is Cal 2? Well, let's talk real quick about Cal 1. So if you could summarize Cal 1 for me, what are some main points from Cal 1? What are derivatives, right? Derivative. The derivative was the rate of change, right? Instantaneous rate of change. And we did a lot of things with derivatives, right? Okay, anything else that sticks out from Cal 1? How about things you didn't like so much in Cal 1? Limits, your professor, okay. Limits. Chain rule, okay, so that maybe would fall under derivatives, but that was an absolutely important rule, right? You had to, related rates. Oh yeah, oh yeah. Related rates and optimization. Related rates. That was like, you know, a sphere is growing at a rate such that blah, 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 right? And then optimization. I'll just put optim. So that's like, you know, the farmer builds the fence and wants to use the least amount of material and blah, 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 right? Okay. How about geometrically? I heard Auntie. We'll get to that in a second. How about geometrically? Like, what did the derivative represent for us in Cal 1? Slope of the tangent line, right? So if we have a graph of a function, right, here's x, and you know, here's f of x, and if we say, well, what's the derivative of the function at a, then this would give us a numerical answer, right? We would go to some value, whatever it is, a. We'd go up onto the graph. We'd imagine a tangent line, right, to that graph. This numerical answer represents the slope of that line, right? That's geometrically what was happening with the derivative. Anything else you can remember from Cal 1 that you liked or didn't like? Or? I heard antiderivative. You probably got that towards the end of the semester, right? How many of you did touch antiderivatives in Cal 1? Just a little bit. All right. Riemann sums. Did you do Riemann sums? Okay, good. All right, so I'll touch on Riemann sums in this class a little bit. We won't go real heavy into it, but we will talk about it because it's important. Okay, so that's, I'll let that be the summary of what Cal 1 was, even though it's kind of short. So what is Cal 2? Well, if in Cal 1 we brought up the idea of the derivative, in Cal 2 we're going to have the antiderivative, which is going to be the reverse process of taking a derivative. So when you take a derivative, we know what to do, right? It's usually going to use some sort of rule, power rule, product rule, quotient rule, chain rule, something like that. And we get some answer when we take a derivative. In Cal 2, one of the main topics is taking antiderivatives or finding antiderivatives, which means going backwards. And this can be very difficult to do. And so we're going to spend the first all the way through almost to March. March 1st is when we actually stop figuring out ways of taking antiderivatives. So we've got a good month and a half of just solid, like, how do you go from something backwards, right? All these techniques. And that's where the homework and the practice comes into play, because you have to see how the processes work, and hopefully it becomes kind of second nature to you, but you can only get that through exposure. So, and then what we'll do is we'll tie some geometric meaning to this, and we'll determine that when you're actually finding, when you have a function, we know the derivative is a tangent line, we'll figure out that the antiderivative is somehow connected to the area under the graph. And then once we understand that that's possible, then we can really blow the doors open, and we can start doing a lot of crazier things, like taking that graph and rotating it. Like, imagine it's two-dimensional, right? It's on a flat sheet of paper, but if we take it and we rotate that around, let's say, the x-axis, it would create this solid. And, you know, the solid might look like, let's see, something like this. Right? Can you all kind of see that? Here's the x-axis going through the middle. We rotate that around. And this solid is three-dimensional, has a volume to it. It has a surface area, right? There's a lot of different things that we can now talk about. And so we'll go try and figure out, you know, what the volume of that is and what the surface area of it is. We'll also investigate taking this graph and, you know, taking it from here to here. Forget the area for a minute. We'll take it off the graph. We'll take it off the piece of paper. We'll straighten it out, stretch it out until it's nice and what? Straight? Taut. What's the word I'm looking for? Taut. Okay, taut. And then you measure it. How long is it? And that would be the arc length of that. And that, believe it or not, is a lot harder to do than rotating it and finding the volume. So we'll investigate that. I already talked about the surface area, which is if you wanted to paint the outside of this, you know, how much paint would you need? And I'm just summarizing here. There's a lot more involved in this, but just to give you an idea of where we're headed. And then we get into Chapter 8, which is the most critical chapter, right? So for those of you who have experienced Cal 2 already, Chapter 8 is going to be that's where you separate the men from the boys. So I'm not trying to be sexist, but you've heard that before, right? I mean, that's where you really get challenged, all right? And that's series, and we'll just get there when we get there, okay? There's a lot in there I don't want to talk about. Just know that it's going to be fun, all right? All right, where's my little list? That's it. I'm ready to get into this, unless you have any questions or comment. I felt like that was a very poor, like, get you motivated for Cal 2, you know? But what I think is more important, you know, because I do a lot of reflecting on what is it that Cal 2 gives you? Like, what's the value of Cal 2 for where you're headed? Because not everybody's doing the same thing, right? How many engineers do we have in here? All right, so a lot. How about computer science? Any math majors? Okay, so yeah, maybe. All those fields are different, and I can tell you that a lot of what we do in here, in your field of engineering or computer science, or even as pure mathematicians, that's a little different because you never get to rely on a computer too much to do your work for you. But in engineering, you know, everything that we do in this class can usually be done with a computer. And in computer science, you actually write the programs to do what we're doing in here. So, you know, what is the value of actually going and doing this, right? I mean, that's a common question. And so I want you to look at this more about not so much the material that's within Cal 2. Look at it as what are you capable of learning, okay? Can you learn this material or not? I mean, it's regardless of whether or not it's important later, this is a challenging topic, and if you can get through this successfully, you can notch that out in your belt, Cal 2, and it means something. It means something to someone who wants to hire you. It means something, you know, on your degree. That Cal 2 is important because this is a high level of thinking in here compared to anything you've done. All right? So that's the value of it. It's maturing as a learner more than can you find the volume of a solid rotated around the x-axis? I mean, you know what I'm saying? Okay, so let's all keep that in mind as we move through. I have some warm-up exercises for you. Everybody ready to warm up? All right, I'm just going to put some problems on board. I'm going to let you work on them for like 10 minutes, see how far you can get with these. I'm not going to collect these. I thought about doing it like as a quiz first day, but then I was like, no, they're going to get the wrong impression. So y is equal to the natural log of x. I want you to find y prime. Or if you don't like that notation, I want you to find dy dx. And 2, I'm going to write the equation xy squared equals sine y. Find, same thing, y prime. Number 3, this is a right triangle. 2, 7, x. Find x. Number 4, another right triangle. Theta is this angle up here. x1 square root x squared plus 1. Find secant theta. So I'd like for the first 5 minutes or so for just you to do this without talking to anyone. And then what I'll do is I'll open it up and you can talk to each other. All right? Any questions on what I wrote up here? This is a 7.
Yes, sir.
Yeah?
On number 2, on the right, equal sign, what's that first?
Sine.
Okay.
So this is sine y. I write in all caps all the time. So. If you don't know how to do number 1, go to number 2. If you don't know 2, go to 3. Don't know 3, go to 4. Don't know 4, well, you had a good break, I guess.
Oh, yeah.
You had a real good break. All right, are y'all ready to make some friends? Yeah? All right, so y'all can have another 5 minutes. Y'all can talk to each other. And if you want to know who your neighbors are, just look down. They've got their names right in front of you. So.
Some of this stuff like algorithms and